going on, let me take the opportunity to call upon Mr. Marcus Ruhr, Director, Global E-Mobility, Schuler present. He would be presenting on topic, moving battery cell housing production in India on the fast lane. Dear all, please welcome him with a huge round of applause, please.
So thank you very much. I'm very honored to have the possibility here to talk at the Battery Show India. So thank you very much for this opportunity and for the introduction. And welcome everybody to this presentation. I will talk about moving battery cell housing production in India onto the fast lane. So I will start with a short introduction about battery cell housings. We'll give you a brief overview about the manufacturing processes. And then I will switch to the challenges one has to face when he wants to produce such products in India. And not talk about the challenges, but also about the solutions. And I will wrap up then with the key success factors which are important in such a supply of battery cell housings. So what we are talking about, I think you probably know there are three formats for battery cells. We have the prismatic, the cylindrical, and the pouch. Today we are talking about the hard cases literally. That means about the prismatic cell and the cylindrical cell. The housings consist usually of a can or case and a lid or lid assembly. I cannot cover all of these components in this presentation, but will take out the cylindrical battery can as an example. I will not cover the pouch cell, which is not a hard housing, but is a soft housing, which has a different challenges and solutions. So when we look at these hard cases, what are the manufacturing processes which have to be applied? As said, I will give an example upon the cylindrical battery cell housing or cell can. So here typically you have metal forming processes at the front end of such a line. In this case, you have a cupping press. So you start with the core material and you apply blanking and deep drawing in the first machine. Then you go on with this cup into the second machine, the so-called PP press, where you apply additional deep draw and wall ironing steps, piercing operations, maybe coining operations. So you finish the can in this second machine from the geometry-wise. In these processes, you apply a lot of lubricants to reduce the die wear. And this has to be washed off the can after the applied forming processes. This is to be done in a washing machine. You wash off these lubricants with typically a water-based washing machine with some detergents. You also remove particles out of the can. Then after the washer, you inspect the can and you pack the can into trays. And then they are ready to go to your customer, to the cell manufacturer. In some cases, this kind of equipment is directly located in a gigafactory. That means in a fabrication in a fabrication. In this case, the cans will go directly after washing through the wall into the cell assembly, typically with a buffer in between. So this is how such a line looks like. We start on the left side with cupping system. Then you see 3 of those PP systems to finish the can. and you have then on the right side the washer, and in between a lot of automation linking of these presses. So this will form then a fully automated line. So now we're coming to the subject, what are the challenges if we want to establish such a production in India? First of all, there is no supply chain. Yeah, because there is no cell manufacturing so far. This is right now built up, but right now such kind of products are not manufactured in India. So you're starting from scratch, which could be also a good thing, yeah, because you can start from a white paper and make the best setup. Your customers are asking for very high production numbers, for very high outputs in the future, not today. So they say, I will have 200 million by 2027. Okay, but how many cans you need today? Maybe 20,000 for some samples. Yeah, so there is a big, you need to think big, but at the same time you have to start small. The product specifications still change frequently. Yeah, so that means the product drawings are exchanged week by week, you can say. Yeah, so you have to react quickly. And when you're talking about such a big investment, you have also to consider that there are already some new technology on the horizon where you don't know, okay, how long this product will be an industry standard, or will, I don't know, solid state or other things come up very soon. So these are the challenges, and what has to be done is the first thing, you look at the cost, yeah, because otherwise you cannot sell the product. For this, we made a cost analysis of such a production in Western Europe, and you see here the results. And what I wanted to point out, because the numbers in India will be for sure different. Yeah, if you look at the labor cost, for example, this is different here when you compare it to Western Europe. But one thing is clear: if you look at the first line, the raw material cost will be the most important cost factor. It is 50%, and I would say here in India it will even be more of the can cost. So the material utilization of the raw material which is incoming in your facility is the key to control the cost. So what can you do to improve that? You have an expensive raw material. For cylindrical cans, it's nickel-plated steel. For prismatic cans, you have aluminum. So it's very expensive. You have to make the best use of it. So you have to try to use a wide coil where you can place a lot of different blanks into it to improve the material utilization. I give you an example. Here you can see a coil where you place 4 blanks into it. And the typical manufacturing in China is to use a narrow coil with 1 out. So this means a narrow coil with 1 out gives you a material utilization by 79%. If you go for 4 out, like shown here, you are already at 86. And if you go up to 8 or 12 out, which would be the recommendation from my side, you are already at 90 or 91% material utilization. So only by this you gain more than 10% material utilization, and we saw this is 50 to 60% of the can cost. So immediately you have a gain in your competitiveness. The other thing is ramping up. The topic, the numbers today are small, but should be big. You should not, let's say, compromise if you want to go on a very high productive system. At the same time, you cannot invest in such a system. So you have to go step by step. So the proposal is to go over time. So T0 would be the starting point. with a system, you grow over time from a basic system to a compact system and a high yield line. You see here the production numbers is an example for cylindrical cells, but the principle is for all parts the same. Yeah, so you start here with 25 million per year, and over time you grow up to 100, 300 million per year, whatever your customer is asking for. The machines, and this is important, where you start with, are also able to be part of such a high yield line. So you don't need to change the machines in between, but just you're adding machines. How does it look like? This is the starting point, the basic line. It's one machine working from a small coil. Yeah, so you don't enjoy the full yield in material utilization. It's just a 2 out, but it's having a relatively small investment where you can already produce 25 million cans per year. The next step would be then the compact line, where you add a small cupping system for 4 out that gives you already a gain in material utilization. You're using the same PP press, and you don't have to change anything on this machine. And then the final step is a high yield line where you use the machine you already had and adding additional machines to have this higher output. The cupping machine at the front has enough capacity to feed up to 6 of these PP systems. So this is a way how you can grow over time. You enjoy a very good material utilization in the latest configuration, and your investment goes step by step. So this is a solution we would propose for the market here to enter into this business. So what are success factors for this kind of production? It is a new product for anybody who starts this production here in India. So the first step is sampling, simulation, process know-how, how to produce it. This is something we can bring to the table. Then you need the machines and the integration of the machines into a production system. And then the most important part, the human resources, so that you need people who understand these processes, who can run this process, monitor, improve over time, and therefore you need to train the people. We also offer the launch assistance over weeks and months or years, where you bring really to the efficiency of the line which is required. And then when the operation is running, the support, remote services, on-site services, and also the analysis of OEE and other production KPIs via digital applications. And this in total gives them the production system which will be successful in India in the production of battery cell housings. So this was very quickly. I could not cover all of the components. I could not cover all of the factors. But if you have questions or would like to discuss some things to me, please contact me. Here are my contact details. And I thank you very much for your attention and for this opportunity. Thank you.
Thank you, Mr. Marcus, for such an interesting session. It was an enlightening one. Dear guests, please a huge round of applause for Mr. Marcus.